All right, we're going to get into some weird stuff. Today we're talking about our introductory to complex numbers, primarily imaginary numbers. It's not like 7 unicorns. It's actually an imaginary number used in mathematics. I represents the square root of -1. In the past, especially in Algebra 1, if you came to a scenario where you had the square root of a negative, you would say no real solution. Now, the terms no real solution, that wasn't just a literary adjective, that was a mathematical classification. Real is a classification of numbers, and that's pretty much all we've dealt with so far is real numbers. But now we're getting into complex numbers, which involve imaginaries. So, the very first imaginary number that we're going to be working with, I represents the square root of -1. So let me show you some examples of how we're going to be using that. If I see the square root of -48, no real solution, agreed. But I can continue breaking this down using I. So we've done factor trees in the past, but here's how I think about it. Take away that -1. All this means is that I is going to be in my final answer, because that will help me take the negative on the outside and just represent it differently. And then 48 you can break down how you have been. And again, this differs from class to class. Sometimes you look for the largest perfect square and then you see what's left, or you do a factor tree. I'll show the factor tree seems to be used more often. We'll say 6 and 8. And it doesn't matter the first factors because you break it down into primes. 6 has 2 and 3. 8 is 2 and 4. 4 is 2 and 2. All right. I look for pairs. There's a pair of 2s. Pair of 2s. So 2 2s are coming out, making it 4. And the I comes out. And the only end root that's left is 3. Done. That's one quick example on how we used I to simplify negative radicals, or negative square roots. So, we're going to do it real quick on the last two. If it's a perfect square, good news, what's the square root of 16? 4. But if it's negative, it just becomes 4i. Okay? Again, if it is not a perfect square, separate that negative first. And then start breaking down. Oh, drop the marker, pick it up, 120. Now, I'll show the perfect square method here. And you don't have to get it right the first time, but I would look for perfect squares. I know 4 goes into this. Well, what's the square root of 4? 2. Now, 30 has no perfect squares that go into it. There isn't a single perfect square that goes into 30. 10 times 3, 5 times 6, 2 times 15. There's no perfect squares. So I can say square root of -1 is I, square root of 4 is 2, so I'll get 2i and 30 left inside. So whether you do the factor tree, perfect square, or look for highest perfect square, you can use I to evaluate any negative radical. Okay, for this next part, simplifying powers of I, we need to step back to the basics. Now, in my class, I refer to this as home row. You remember keyboarding, home row? HJKL. I don't know, I'm not good at typing, don't judge. But I can use these 4 to find any power of I that I'd like. I is just square root of -1, so you can, essentially that's just I. But what if you get I squared? Okay, now we start dealing with some things. Keep in mind, I squared is really square root of -1 squared. Well, if I give you the square root of 2 and square it, the result is just the inside. This same skill gets applied to complex numbers as well. If I square a square root, my result is just the inside. Okay? And when you get to I cubed, think of it this way. I squared times I. Well, what's I squared? -1. -1 times I, -I. Lastly, I to the 4th. Well, that's just I squared times I squared. So what's -1 times -1? 1. Now I stop after 4 because if I went to 5, well, look what this is. It's just I to the 4th times I, right? What's 1 times I? I. And you'll notice now my cycle is about to repeat. So that's good news. There's the pattern that we're going to use to apply to evaluating any power of I. Every fourth power resets, resets, resets. So if I can find the nearest power of 4, my life's really, really easy. Let me show you what I mean. 54, huge number. I don't have to write out I 54 times and then start trying to cancel. I'm intelligently lazier than that. So here's what I do. The number 54, I think of what is the nearest multiple of 4 to 54. Now again, I realize most of you only go up to 40. Well, okay, keep going 40, that's 10. That's 14 more. So it goes into 12, put those two together. The nearest multiple of 4 is 52. Okay, now that's just arithmetic. You can use your own math there. How much is left to get to 54? I squared. Okay, now, I to the 52nd. Keep in mind, 52 is a multiple of 4. We just said every fourth is still just equal to 1. So I to the 52nd is really just 1. I to any power that is divisible by 4 is just 1, because it resets every fourth. And then I go to home row. What's I squared? -1. So I to the 54th is just -1. Works every time. Let's try another one. 73. Again, a big, nasty one. Divide by 4. Okay? The nearest multiple of 4 is 72. So, how much is left? Only one I. Well, I know I to any power that is divisible by 4 is just 1. And I is just I. So I to the 73rd is just I. Works over and over again. 2 more. All right, these real quick. This one's a little easier in our wheelhouse. What's the nearest multiple of 4? 8. By the way, it doesn't work. You can't go over. It's like Price is Right. Got to be underneath it. There's 3 left to get to 11. That is a multiple of 4, so it's just equal to 1 times I to the 3rd. Home row, -I. So your final answer is -I. Last one, 44. Hey, that's divisible by 4. So what's it equal to? 1. That's a quick tutorial on introducing I, how to evaluate negative radicals, and evaluate any power of I.